Good afternoon. My name is Andy Michel. I'm the product manager that oversees Game AI at Qualcomm. I'm particularly delighted to share with you today's presentation, where we'll be covering our latest innovation in-game experience, that is the Game AI SDK. And before I start, I would like to acknowledge a group of people who worked proactively over the past year to bring this project to life. From a team that covers engineering to producers, we have a full in-house gaming studio. They work diligently to bring this vision, that is a new class of gaming experiences that's running locally on device to minimize latency, minimize cost, but also increasing gameplay session. So with that, in today's talk, I'll cover what's changing about Gen AI, the recent trends that we're seeing, especially across modalities and devices. I'll talk about the unique challenges that we encounter at the edge, that is in power-constrained environments. I'll talk about how gaming specifically is impacted by generative AI. I think there is a migration that's happening from classical algorithms to generative capabilities in gaming. And finally, I'll dive into the details of the SDK. And this is a great deal of work to simplify the workflow of gaming so that every studio doesn't become an ML engineering team while providing as much flexibility as possible so you can customize your experiences. And then finally, there is a quick demo on how we're looking at AI NPC on device, which is one of those experiences we're looking to enable and in the broader landscape of experiences. And so we'll highlight some of those, the 4 key experiences that we're experimenting with. So with that, I'll start with the general trends on AI. So when you think about how generative AI has scaled since 2022, we're seeing a slight shift from chatbot general Q&A interactions to more agentic capabilities, where AI is having the ability to take actions autonomously on behalf of the user. But what we're seeing as well is a shift from modalities. So instead of just conversational AI, you're seeing audio input, visual input, and actions being derived by the AI itself without being prompted to do so. And so in that sense, we're looking at AI across different device form factors and how to offload those capabilities in a way that is seamless to the user, so that if you're playing a game on your phone and you transition to a powerful PC, the experience remains the same. And so at the core of that, there needs to be a smart orchestration layer to be able to offload those capabilities as you shift from one device to the other. But to make it truly playable, we need to figure out how to ship and how to minimize latency, but more importantly, how to maximize the length of your game session, that is minimizing battery consumption. And so we look at 4 distinct areas, and we'll talk about AI NPC, we'll talk about AI teammate, AI coach, and finally, we'll look at AI companion as well. So the intent here is to fuse different modalities of generative AI capabilities, from audio to visual input, to text input, to voice input, to fuse them into one so that from a game development perspective, all that is seamless to the user. So then to really paint a broad picture, we look at generative AI capabilities across 3 swim lanes. And generative content in gaming is a very thin line, and to our view is that AI enhances rather than replace productivity. And we're looking at that from code generation to asset generation. So take a producer or a designer who says, I want a sword of this type. You generate a 2D asset, convert it into a 3D mesh, and you bring that into the game. And so those are the capabilities that we're looking at. So the first swim lane is the asset creation pipeline. That is, how do we minimize the lag from content creation? How do we increase the iteration speed so that we can bring creativity at the speed of thought? The second swim lane is in-game interaction. That is, when an agent is running in the game, how can you create dynamic experiences such that when you interact with the agent, it is a personalized experience, but more importantly, it is also dynamic, so that at any point in time you interact with multiple agents, you get a new experience as opposed to a scripted and a very rigid framework. And then finally, there is the graphics and rendering swim lane. That is, how can we leverage the power of generative AI or AI in general to do things like frame resolution or super resolution or frame generation. And so across those three swim lanes, there are a number of use cases: content generation, in-game interactions, and finally rendering. And so for the purposes of this talk, we'll cover each one of those in broad strokes in terms of how the Snapdragon hardware enables fast on-device inference at minimal cost. And it's worth pointing out how there is a trend from large models that are good at multiple tasks to individualized models, smaller models. So we're seeing a trend from 70 billion or 100 billion parameter models to models that are 5 billion parameters, but they're really good at a particular task. And so in gaming, you may find that a specific model for, let's say, a conversation, let's say a Qwen 5B, is sufficient for your use case. Or in other instances, for instance, in agentic like use cases, you may find that a bigger model renders more capability. And so we look at generative AI, especially gaming, across the different products that we offer. So whether that be on mobile, whether that be in the car, or whether that be on your PC. And generally speaking, those are the model sizing that we support on our platform, and which is effectively very performant if you think about it from a broad scheme. And the key thing that's worth pointing out here, there has been a series of innovations to allow fluid and cohesive experiences. So one of those is larger context windows. That is, you interact with a character and you come back to it, it remembers the previous interactions. The second one is multimodality. That is, a character can see, hear, and process the game state in real time and act without the user having to submit a specific prompt. The other aspect of it is concurrency. So if you think about immersive experiences, you may have multiple concurrent models running at the same time. An example of that would be in multi-modality use cases where you may have a vision pipeline, you may have an audio pipeline, you may have a generative pipeline. And in some cases, you may have legacy engines that are based on behavior trees, and then you have a large language model as well. So our platform has the ability to run the workload where it's best suited. And so across these products, our innovation is to combine all those technologies in such a way that is easy for the game developer, whether an expert or not, to bring AI technologies into gaming to create customizable experiences. And so with that, I would like to take this from theory to practice and introduce the Snapdragon Game AI SDK. This SDK is built on 4 key principles. That is local inference, native engine integration, that is power efficient and hardware optimized. When inference happens closer to the user, the experience becomes seamless and repeatable. And as we look to partner with native engine developers to make this as easy and accessible to developers directly from the editor, so that you can drag and drop, or you can go behind the scene and leverage our easy APIs to implement complex pipelines. And so the intent here is twofold. 1, easy to use. 2, power efficient. And all that running on device. And we'll dive into more details about the specifics of the Game AI SDK in a moment here, but it's worth highlighting why this is possible. Is the platform ready to support those kinds of workloads? And so from a top-line perspective, if you look at the kind of performance that we've delivered on our platform. So on mobile, year over year, our Adreno GPU has improved about 23%, which amounts to 25% in ray tracing improvement. So your experience in visual quality consequently is better as a byproduct of the fact that our GPU is improving year over year. Second, there is our Orion CPU, which over the previous generation has improved by 32%. And that means the responsiveness of operations that are running on the CPU, this could be simple things like semantic search, is that much more rapid and with minimal latency. And so all of that combines for a powerful CPU and GPU combination. And finally, I would like to highlight our NPU, which is our Hexagon processor that has the ability to run AI workloads very efficiently, particularly when you start to look at agentic AI. And one of the things that's worth mentioning is context length. And so that is, if you have one agent or multiple agents running in the game, you have the ability to go back to each one, and they have the context length in the memory to recall previous conversations, previous actions. So overall, you end up with a very dynamic and easy workplay, such that when you go back to an agent, it's not playing a script over and over. You can generate a new experience based on the input you provide to that agent. And then finally, it's worth mentioning that we have camera AI capabilities as well in sound performances to combine for a powerhouse of hardware performance that's running on mobile. But that's not it. On PC, we have a similar performance package as well. So when you look at our NPU sports 80 TOPS, that enables you to run a lot of operations on our platform. And similarly, our GPU has also improved to deliver smooth gameplay and more complex rendering pipelines. And finally, we have faster memory bandwidth and robust connectivity as well, so that in a scenario where you're distributing your workloads across the edge and the cloud, you'll have minimal latency as data traverses from the edge over the wire to cloud servers. So our platform, both on mobile and PC, enables gaming not just at peak performance, but sustained performance. Smooth gameplay, heterogeneous compute, and AI enabled. So diving into the next level of details on our hardware. So when you look at Game AI use cases, we'll try to map them across the relative IP blocks that they belong to. So starting with the CPU. The CPU enables small, low latency, and bursty use cases. As mentioned, text processing is an example, or some vision use cases like recognition and detection. And our sensing hub is always-on AI. And what it enables is voice UI triggers, audio context, and finally, sensor awareness for always-on capabilities. That could be audio processing, which we'll dive into later. Next, we'll look at our GPU. Our GPU is equipped with technologies for super resolution, frame rendering, and frame generation, and neural rendering. So all that enables maximum performance at low power running on both our mobile and PC platform. Finally, we'll look at our NPU, which really is the bedrock to enable Game AI experiences. That is, bringing large language models, large visual models, quantized for our platform to minimize the power footprint, minimize the memory footprint while running very efficiently. So you get longer battery life with minimal impact to game performance. And some of the use cases we think about are anti-cheat game highlights, ML agents and LLMs running on our NPU, while we may still leverage the same NPU for other use cases like voice and audio. And finally, camera, so for more robust image use cases. And so all that is our Hexagon NPU targets performance-heavy workloads. Game ML agent is an example, but you can think about as you scale to agentic AI, it becomes more critical to have a performant IP dedicated specifically to run those types of workloads. And in practice, as mentioned before, it's worth thinking about a hybrid architecture such that the workload is running in the cloud based on the type of use cases. And we'll dive into that in a moment here. But we primarily think about the edge as the foundational environment to run AI workloads. The closer it is to the user, the less the latency you incur. But more importantly, the user's private data remains on the device. But more importantly, you can customize those experiences. We've talked to a number of studios that are looking to create unique experiences per user. That is, you and I are playing the same game, yet our character or our teammate behaves in a way that is uniquely designed for us. And so with that, the opportunity for Game AI is hybrid. The strategy is you leverage a unified AI stack based on the Qualcomm technology, based on the Qualcomm hardware, and deploy both on our cloud-centric product, that is the AI 200, that is suited specifically for Gen AI work use cases. And then finally, at the edge, leveraging our Snapdragon NPU. Now, the unique opportunity here is that you build and write your code once, and it is suited both for the cloud and for the edge. And the kind of use cases we think about at the edge are things like guardrails. So in an instance where you create a personalized experience or an autonomous agent and you want to apply some guardrails. In those cases, if the user goes offline, it is critical to have safety in place. But when you think about the cloud, there may be opportunities for things like live ops. And so the general trend in AI is that we're seeing a migration from training to inferencing. And this is why our technology, both in the cloud and at the edge, is best suited to minimize the cost of inference while increasing responsiveness. And so diving into the next level of detail here, so if you start as a baseline, that is, everything runs in the cloud today. So from audio processing to guard models to various pipelines, for instance, intent recognition or RAG and LLM. If we start from that baseline, that is very expensive in multiple factors. One is cost. The cost of GPU utilization and the cost of token generation. Number two is latency. In a lot of instances, you have a distributed infrastructure where you have a voice server, you have an LLM server, you may have a TTS server. So the opportunity here is to scale towards the edge. That is, there are a number of building blocks that can run on device and while still not sacrificing the performance. So an example of that is ASR, for automatic speech recognition. And Qualcomm has pioneered an ASR technology that is performant in hardware first to ensure that it minimizes latency while increasing accuracy. Secondly, text-to-speech. And so if we were to take just those two building blocks and running those on device, it minimizes 2 round trips, potentially to 2 distinct servers. Hence, it's smoother gameplay to begin with. Now, as we think about scalability, you want to think about bringing other components to the device as well. And some of those components can be decided based on the complexity of the use case, the constraint of the device it's running on, whether that be mobile, PC, or in auto, or whether that be a simple AI NPC interaction, whose role is to simply maintain a basic conversation, general Q&A, such as an AI companion, or a more complex use case like an AI teammate. So down here, I'm showing a table that gives you a general sizing, a practical sizing in terms of how you bring some of these models on device and what types of use cases are they best suited for. For intent recognition, you might use a smaller model, but for more complex use cases like reasoning, you might use a larger model. And what we've seen is that in a lot of those use cases, an 8 billion parameter model works sufficiently well. And if you recall the previous slide that I showed, we do that extremely well on our mobile platform. we go up to 10 billion plus parameter model. And so an 8 billion parameter is well suited within our power and performance envelope. Whereas in other use cases, larger models can run on the cloud, inferencing on our data center platform. And in a lot of those instances, what you find is your infrastructure becomes use case specific. That is, the complexity of the interaction that you're looking to have with the user will drive this model sizing, your pipeline, and whether or not it runs on device or it lives in the edge, or it runs in the cloud. And so ultimately, this provides you with a holistic view of the different pipelines you can plug or reduce to bring AI into gaming, running on the Snapdragon platform. And some of the things that's worth mentioning here as well are things like the right model size with the RAG pipeline and the right memory block can unlock a unique experience for the user. That is, using the game lore to fine-tune the model and using memory to retain context about the user. That could be either user preference or previous interaction. So holistically, looking at this general practical guideline, you can leverage a Qualcomm hardware to bring AI into gaming and create innovative experiences while not impacting the gameplay. Finally, if you look at a more complex use case, so we leverage the same backbone that, for instance, an AI NPC or an AI companion would leverage, that is your conversational AI pipeline with memory to recall context and potentially some tool calling as well. We bring the same backbone into agentic AI. Now, that agent has the ability to process visual frames, has the ability to look at game state, has the ability to process audio from the player. That is, watch my back. A simple command that is decomposed based on intent, based on environmental cues, but more importantly, based on the user's objective. That is based on the specific gameplay in the environment. And so ultimately, the thing that's worth pointing out here is the agent brain. So can you see my mouse here? Okay, agent brain. And what we're seeing here, as in addition to the pre-existing backbone that I showed in the previous slide, what we're seeing is people are leveraging visual language models for various types of use cases. So instead of having specific vision pipeline and audio pipelines, you can leverage bigger models and fine-tune those for the game. And then finally, based on your device constraint, you can figure out what lives where. So for instance, you may have short-term memory live on the device, but for long-term cross-player orchestration, you may have a long-term memory that lives in the cloud. And so ultimately, this shows that an agent has the ability to see the game state, it has the ability to act autonomously, and it has the ability to incorporate various modalities to create a richer game experience. So now, let's transition back into the three categories that were mentioned before. So we talked about the content creation pipeline, we talked about the agentic in-game interaction, and we talked about the graphics and performance pipeline. And so for the rest of this talk, we'll talk about specifically the AI agent in-game interaction pipeline. And this is what the SDK enables you to do. That is, create new experiences with agents that are running in real time. I would also like to highlight that my teammate from the GPU team, they were giving a talk this afternoon to talk about the latest innovation in graphics. So transitioning to the four key experiences that we mentioned before. So there is the AI NPC, that is non-playable characters that have the ability to speak. Unlike previous infrastructures, these agents are dynamic. Then there is the AI teammate, which is the closest thing to agentic AI that we'll get. And we described that agentic pipeline a moment ago. So it has the ability to see, hear, and act autonomously. And there's the AI coach that has the ability to help a player define or fine-tune a specific skill. That is, in a new game, the coach will watch as the player is interacting with the game and provide tips in real time. And there is the AI companion that has the ability to remember past performances of the player and has the ability to do intent recognition and emotional resonance, so that as you play the game, it's not just a bot, but it's a bot that is personalized to you. So all that is to say that our platform and this Game AI SDK has the ability to enable these 4 key use cases using the same primitives that are defined for an AI NPC all the way to an AI coach, which is a very complex use case. And so to make this real to developers, we think about portability, we think about frictionless integration, and we think about usability. That is, create components that are easy to use, that are performant on our hardware, that hides the complexity while providing as much flexibility as possible, and all that running locally while minimizing the costs that we mentioned before about latency or token generation. So we'll take a deeper dive into the Game AI SDK. We mentioned before, code once, deploy everywhere, whether that be at the edge or on our cloud. You still use the same AI stack, and you leverage the NPU that is running on device. And across the board, you can look at both on the Android and the Windows ecosystem, we have a layer of abstraction that unifies the APIs, so that you write your code for your capability, but not the specific platform, which eases deployment and maintainability. The second thing is to bring the uniqueness of each character to life. We incorporate RAG in memory. As mentioned before, it has the ability to get context about the game and also remember previous actions. And to scale the developer ecosystem, we make it such that our hybrid strategy allows the developer to choose what runs where based on the kind of workflow they're looking for, or that be a complex workflow, or where that be a simpler one. And so that level of flexibility allows one to define experiences once that can be deployed across multiple devices, whether that's the PC, the auto, the mobile, or potentially XR glasses as well. And here we dive into the specific plugins that are part of the SDK. So to start with, we have an LLM pipelines that provides direct access to our RAG and memory APIs. Secondly, we have a speech recognizer that is based on our voice AI SDK. This proprietary SDK runs efficiently on the hardware, and we have the ability to run it on the eNPU as well. So that is the embedded NPU. And the embedded NPU can run passively at even lower power than the NPU itself. And then finally, we have text-to-speech. Right now, limited to Android, but looking to scale to Windows very, very soon. And so the intent here is that we've packaged the right level of plugins that can run on different parts of the hardware and targeting both Android and Windows platforms. So you can develop your experience once and deploy seamlessly on multiple targets. And then finally, I would like to highlight the series of models that we support today. This is not a finite list, as we continue to experiment with multiple models. And the developer has the ability to bring in their own models as well. So for instance, if you have customized your own large language model or visual language model, you can bring that into the SDK using our quantization and toolkit. You can run it efficiently on our platform. And finally, we'll dive deeper into our underpinning technologies to enable all of this with with ease effectively. One of the challenges that runs, that is notorious in the developer community, is leveraging tools that are disjointed and having to figure out how to migrate from one framework to the other. By leveraging our stack, you use the same toolkit for end-to-end application development. So what that enables you to do is start from the hardware. We talked about the CPU, the NPU, and the GPU a moment ago. And the heterogeneity of this architecture enables one to not allocate specific operations to specific IP block. The hardware is smart enough to figure out where it needs to run the operations in the most efficient way possible. And then as you scale up, you look at the operating system. Here we'll make it such that if you're developing on multiple targets, we can abstract away some of the complexities. And then as you navigate up the stack, there's a series of developer libraries. And so while we do make it as simple to use as possible, we do provide you with the handles to dive into the details and customize your experience as you see fit. And one of the examples is our SDK, sitting at the very top of the stack, creates very simple APIs for voice and language processing. Now, if you would like to get more control, all the way down to graph compilation, you can do that as well. Now, it is not my impression that game developers want to be AI engineers. And so we create an abstraction layer to make it as easy for the developer to use as possible, while still providing access if they want to dive into the granularities of how they want their operations to run. And so as you can see on top of the stack here, there is the there's the Game Engine SDK, which is the Game AI SDK, the Snapdragon SDK that we're talking about today. And then there's a set of application SDKs as well. And so if you would like to customize your voice experience or your large language model experience, you can dive into the application SDK and customize that yourself. But ultimately, if you're to leverage simply the Game AI SDK, it enables you to create unique experiences with minimal code as possible. And so ultimately, our stack is customized specifically for gaming. It is not a one-off framework that enables you to customize one experience and having to convert to a different set of binaries or platform for it to be performant. And so we look at optimization across the entire stack, from the hardware to the operating system, to libraries that are provided, to applications and frameworks, all the way to the game engine itself. And all that is to point to the fact that Qualcomm is pioneering the next wave of experiences with the maximum amount of performance running on devices possible. That is, the notorious challenges that we run into is how do you run a large language model at the edge without draining your battery? Now, we're proud to say that we have our Windows and Snapdragon platform as well. So I encourage each one of you to try the SDK and customize the experience and try running on Snapdragon. And with that, I would like to introduce our Voice AI SDK. This application SDK is customized specifically for voice, and it has a series of modalities, from batch processing to streaming. There may be instances where batch processing is sufficient. So for instance, if you want to process a speech 5 seconds at a time, or if you want nonstop speech processing. Now there's trade-offs. One is memory and power consumption, but you have the flexibility, depends on your experience. And some of the things that's worth pointing out as well is our Voice AI application SDK is specifically suited for different types of environments. So for instance, it has the capability built in for noise suppression. And in a moment here, I'll show a couple of demos about the Voice AI SDK. And it also has the ability to do non-speech detection as well. So if you're playing in a noisy environment, it will not pick up cues from the environment and try to process those. And all that minimizes your memory consumption, and also it minimizes power consumption as well. So finally, we provide a series of notebooks that you can easily use. If you want to swap to a different model, you can do that as well. As we keep an eye on the open source community to ensure that we stay up to date and use the latest and greatest models that are available to developers. So with that, I'll play a short demo here that'll show how our Voice AI SDK is being used in real time to do noise suppression.
Fang, what's your plan for the spring break?
I'm gonna go to Japan.
Where in Japan?
I'm going to Osaka.
Qualcomm's voice AI ECMS
Oh, that sounds
is
fun.
specialized
What is
in
World
helping
Expo?
AI
So it's a
understand voice
convention
and mitigate
like
interference.
flying cars.
Oh, that sounds pretty cool. Don't forget to take a lot of pictures.
It
Oh, I
allows
will. Have you
users
been to
to
Japan?
perform
No,
voice
I
AI
always wanted to
tasks
go. But I heard
effortlessly,
it rains a
even
lot
in
December.
challenging
Oh,
noise
you should go in
and
the
echo
spring to see
conditions.
the cherry blossoms and stuff.
Yeah, that sounds amazing. Anyway, hope you have a good time.
Thank you.
Have fun.
And so what you're noticing here is there is a foreground speaker, and then there are background speakers as well. So imagine if you're playing your game in a coffee shop or a noisy environment. Our Voice AI SDK has the capability that is fully integrated to minimize the noise that's running in the background. And so what that entails is the amount of tokens that's processed on device is also reduced. And in other instances, you may want to do things like more interaction with in different modalities. And so our next demo here will show a prototype that we're working on to do things like look and talk. That is, if you look away, the ASR engine will stop recording voices. But if you look at it using the camera feed, it can detect that your intent is to process a command or audio. And so this is that demo. Now, it's worth pointing out that this is very much in the early phases of prototyping. Our view in our gaming organization is to look beyond what is possible. That is, how can we combine different modalities to create unique experiences for gaming? And you would never think that fusing vision and voice is one of those experiences. Well, our team is bold enough to prototype with those capabilities. And so what you'll see here is a person interacting with the model, and while we have a camera feed that's capturing the user's face in real time, so performing tracking and detection in real time. And when the user looks away, you'll see that our ASR engine stops recording, but then looks back at the camera, then the user, the ASR engine starts processing the speech. And so the intent here is to create, again, easy to use types of interactions for the user.
我们将要展示的是多模态唤醒新增的功能 Look and Talk。我现在没有看着手机，手机是不会唤醒的。我现在看着手机，它是应该会唤醒的。我现在没有看着手机，它是不会唤醒的。我现在回来看着手机，它应该会继续唤醒。
可以唤醒吗？
然后现在我看着手机说话，它应该会唤醒。
So this highlights where we're going beyond push to talk. And we'll dive into how we're combining the foundational technologies that we're developing in voice AI to bring those into gaming. So leveraging noise suppression and some of the early prototypes like look and talk, we can create a set of primitives that are foundational for in-game interaction, let's say for an AI NPC. And the way we think about this is there is a standard set of enablers. Today we have things like activity detection, multi-language translation, and transcription. And we have a set of models that we support. So Whisper, small and medium, and we also support ML2TS for text-to-speech as well. And finally, we have different quantization schemes. So for instance, we can take a floating point model and convert that to integer. And the reason you do that is because it reduces memory footprint and battery consumption. And the core features that we bring into gaming are things like multimodal action. As shown a moment ago, you can connect your camera feed to an ASR pipeline and create those types of capabilities such that a user or a player has seamless, intentful interaction without having to confine himself or herself within the linguistic framework that you would typically have to use to interact with a large language model. As shown a moment ago, you also saw noise suppression. That is, again, seamless to the game developer. You use the SDK, and it's available to you. Now, to make this as easy as possible for a developer, we have the first plugin, which is the speech recognizer. So this is currently available in both API form or via blueprint in the Unreal editor. That is, you can drag and drop to create experiences, or you can code behind the scene. And the speech processor handles capture recognition using the Voice AI SDK on the NPU. Now, as mentioned before, you can leverage the eNPU as well, which is an area that we're actively looking into based on the use case. But early experimentation shows significant improvement in performance. Next, we'll talk about the text-to-speech plugin, which is a wrapper around the core text-to-speech functionality that is managed behind the scene. And so far, we have a series of models that we've tested that are both available on Android and Windows. For the initial release of this SDK, we have a model that is published for Android, and we're working on optimization for the Windows SDK. So ultimately, as you can see here, still leveraging the exact same stack, except the plugins are natively built to be performant for gaming. Next, we'll talk about our Genie SDK. The Genie SDK is the core engine that drives generative AI capabilities like LLM with a series of control. Now, to make this performant, we offer a series of features from low rank adaptation to context length and memory management. So this highlights the capabilities around the types of dialogue and advanced execution control that a developer may want. But out of the box, you can leverage the high-level APIs to bring any LLM that you want in gaming. And on top of that, the Game AI SDK packages the LLM pipeline into an Unreal-friendly set of components, similar to the text-to-speech plugin, similar to the speech recognizer plugin. We also have a plugin for the LLM pipeline as well. And the four key components that you're looking at are the LLM model wrapper, the conversation engine for prompt and function calling. There is the vector DB, which is relevant for RAG, if you want to implement a RAG into your pipeline so that the model is more accurate and leverages the game lore so that answers are grounded within the context of the game. And then finally, we have the embedder plugin as well, which provides the ability to build the vector database. The key takeaway here is that an LLM pipeline that is production-oriented gives you as much flexibility as possible. And we're looking at different modalities as well. So some of the early prototypes are leveraging visual models, are leveraging multimodals as well. If you recall in the previous slide that I showed the sizing guideline, now a developer has the ability to bring in any model that they want. They can run on our platform. And this is seamless to the user. If you want to use your own custom model, you can bring that into the fold. Or if you want to leverage an open source model, you can bring that into the fold as well. And in a moment here, I'll show the existing ecosystem that we have in a marketplace full of models that you can download and experiment with. And the SDK will be shipped with a model that is tuned specifically for the gaming experiences. And so you have three potential avenues to bring generative AI into gaming. Now, if we look at the LLM pipelines from a top-down perspective, I mentioned that we have a heterogeneous architecture that enables you to choose where you run, or that can run the operations based on the hardware backend that is most suited for it. but you do have the flexibility to map specific workload to an IP block. So an example of that would be if you run an ASR pipeline on the NPU, you can choose to run either the TTS on the NPU or the CPU, provided that you're running the LLM on the NPU. The intent here is to do workload management. That is, based on the model sizing, based on the model capability, you have the ability to choose where to run what. And then finally, you have the game that spans across the GPU and the CPU as well. And the intent here is to deliver dynamic experiences using generative AI while making it as easy to use for the developer as possible. One of the core functions we kept in mind as we developed this SDK is how can we lower the barrier to entry for the developer? That is, making no assumption whether you're a novice or an expert in AI, how can we deliver AI experiences that's running on our platform? And those pipelines enable you to do exactly that, especially if you're using the plugins that we provide. You can go in the editor and drag and drop, and off you go. So with that, I will show a final demo that shows how we're leveraging an AI NPC into gaming. That is, processing audio in real time and reasoning about the implications within the game.
Hey, you must be Blue.
Yeah, that's me. What do you want?
I'm with Project Zero.
Uploading data. Data upload complete.
All right, see you around.
Later. Don't let the door hit you on the way out.
So what you've just seen is a combination of all the core technologies we talked about. That is, a performant hardware, an AI stack that is robust from the operating system all the way up to the application level, a set of technologies that are driving simplicity while delivering performance, such as noise suppression, and a large language model that provides an easy-to-use interface. This could be customized for general Q&A or fine-tuned for action-specific models, while also delivering the toolkit that enables you to go one level deeper. That is, you can use lower adapters to create a customizable experience or define the character of a specific player within the game. Or you can use other techniques like speculative decoding to minimize latency and token generation, all that running on device. And so to wrap this up, I would like to highlight the key innovations that we're delivering on Snapdragon via this SDK. First, you get performant ASR, context-rich characters, and efficient TTS. The key value proposition here is that all that is running locally on the user's platform. That is no round trip to the cloud, no cost in GPU or token generation. And this enables you to customize your experience in whichever way you see fit. Depends on the game, depends on the outcome, depends on the story that you would like to tell. And we're looking at more robust scenarios as well to generate assets in real time. So for instance, a player has the ability to ask a character to generate a weapon of a specific type with a specific set of capabilities. And you can use a model to generate that asset in real time. And so we're experimenting with those as well. So ultimately, what I would like to highlight here, if you're taking anything away from this conversation, is that we have an edge AI stack that is mature enough to support different types of workloads, but more so flexible enough to allow the developer to customize it based on their specific platform, based on their specific use case. All that running on Snapdragon hardware. And end-to-end, from the hardware to the OS, we'll make this as seamless to the user as possible. Now, finally, I'll talk about what we're doing from an ecosystem perspective to facilitate development. So as mentioned before, you can bring your own model. The way that looks in our existing workflow is you can visit the Qualcomm AI Hub. There's a series of models from convolutional neural networks to generative models that are available that's already been quantized for our platform. So you start with picking your own model from the existing catalog of models that are accessible, and you can develop with that model. And if you would like, you can bring your own model as well, whether that be ASR, or that be a large language model, or a traditional ML model, like a CNN. And you can deploy on our hardware. That is both targeting our PC platform or our mobile platform. And as mentioned before, across our entire stack, the PC and the mobile platform are equipped with the CPU, the GPU, and the NPU that have delivered top-tier performance to minimize heat generation, to minimize battery consumption, to minimize memory footprint while still delivering top-tier performance. So with that in mind, I would like to transition finally to accessibility. That is, I know you guys can't wait to use this SDK, and I would like to make it accessible to you. And so we have a series of QR codes here. I would invite everyone to scan those QR codes. So the first one leads you to our developer hub, where you'll find all the associated tools with the SDK. The second one is a blog that we've published that shows our vision and highlights some of the details about what makes this SDK unique in its platform or unique in its class to deliver key experiences. And then finally, as of today, you have access to the source code and all the plugins that are associated with the Game AI SDK. That is, you can go on GitHub, download the plugins, customize them, use any existing models, or leverage the one that's packaged to create an AI NPC. And going forward, we'll be looking to develop more complex use cases and make that available to our partners and studios so that gamers are excited about AI in gaming. That is, create dynamic experiences for players while retaining attention, while minimizing power, and certainly elevate the gaming experience with AI. Thank you.
Do we have any questions in room for Andy? So please step up.
Question in the back there.
Thanks for the talk. That was great. So I'm from a company called Meaning Machine, and we have our own sort of game-conscious AI stack that we use. And for our games and for our partner studio games, we're very happy with that level. But at the model orchestration layer, we're agnostic. So I guess part one of my question is, are we able to take your hardware optimization running on Snapdragon, and can we put that at our model orchestration layer? And then secondly, you were talking about the OSs you support, and I noticed like iOS, Mac, Linux is not on there. So if we did take that approach, would we be swapping it in when we're on the platforms and hardware you support, and then swapping out for something else?
Yeah, so just to recap the two questions for me one more time.
So one is that we have our own AI NPC stack that we're very happy with and studios are using, but the model orchestration layer is agnostic. So can we swap in your hardware optimized model orchestration into our stack and just use that part of what you've been working on? And then secondly, like in terms of platforms you support, it looks like it's just Windows and Android. So
Yeah.
we would use something else for those platforms, I guess, and
Sure,
other
sure.
people would as well.
Yeah, so two really good questions. So the first one is, you do have the ability to do that. So if you look at our layered approach, we have the Genie SDK, which probably is the entry point that you would be most interested in, that has the ability to allow you to customize the LLM experience and generative experience on device. And so suppose that you didn't want to use the higher end of the stack, you're able to dive at that layer and leverage that SDK to, again, run on our platform. And then number two, we're looking at scalability. So this is the first iteration at releasing this SDK. We're very excited about its potential. And the intent here is to increase our footprint on as many target platforms as possible. The intent here is that we want to give game developers the ability to build once and deploy everywhere. And that's partly the reason why this is open source. We want to invite contributors to customize and give back and help us steer the development of this SDK, while still keeping in mind that on Snapdragon, given our hardware performance, you're likely to get a better experience compared to potential other platform. But at a foundational layer, we're looking at agnosticity and deployment reach as the key drivers to ensure that when you develop an AI experience, you don't have to customize it for a specific hardware backend. All that is seamless to you.
Great, sounds good. Maybe I'll find you afterwards and we can chat a bit more, I think.
Sounds good.
Great.
Cool. Can we get one final question for 5 minutes left, and we'll ask everybody to take it off?
Hi, I'm Kieran. I'm a student at DigiPen. I've been studying like open dialogue systems and like LLM kind of driven characters. One of the problems that usually arises is from the like user experience side, because when you have a sort of like, you can talk to the character, the input into the system is like non-deterministic essentially, because people can just say whatever they want.
Yeah.
The AI's response to that is then also non-deterministic. So my question is, what tools would like narrative designers have to guarantee the gameplay experience they want to deliver when the player has kind of like free reign of driving the conversation?
Yeah. You know, it's a very good question for a few reasons. So the first one is, there is a certain level of unpredictability that you do want to unlock when you interact with, you know, an agent or a generative model in the game. So you don't want to lose that, but you still want to have a framework in place to limit the range of possibilities so that the interactions are productive. And so there are a couple of ways here. So one of those ways is leveraging, fine-tuning so that the model stays grounded within the context of the game, as opposed to being a general chat model. That's number one. Number two is skill development. That is, we're seeing a trend from using large models to very small models that are very specific at a particular task. And so if you train a model for that specific task, the likelihood of it going beyond that is relatively low, while still being able to act in a dynamic fashion. And number three, given the fact that these interactions can be dynamic, there needs to be a layer of protection for the user, such that the model does not produce something that is harmful to the user. Inversely, there needs to be gating factors such that the model itself is safeguarded from the user, so that the user does not abuse it. And so all those are areas that we're actively investing in to ensure that we have the right level of API access available to developers so you can customize your interactions with AI in gaming.
All right, thank you.
Thank you.
All right, for those up in the room, please give me another warm thank you to Dr. Andy Michel. Thank you.
Thank you.